Hello friends, welcome to lecture 3 from Digital Logic Design. Today's topic is decimal to binary, decimal to octal and decimal to hexadecimal conversion from number system conversions topic. Now let us take the first conversion, decimal to binary. To do this conversion, we have to follow two steps. The first step is divide integer part with 2. In this given number, before decimal part is integer part, this is fractional part. So first divide integer part with 2 and then take remainders from bottom to top. Similarly, for fractional part, multiply fractional part with 2 and take integer values from top to bottom from product values. Now let us do this conversion. The given number is 436.7 with base 10. Here this is integer part, this is fractional part. Now divide this integer part with 2 and multiply this fractional part with 2. 436 by 2, this gives 218 with remainder 0. Again divide with 2, 109, remainder is 0. Next 2 5s, 2 4s, remainder is 1. Again divided with 2, this is 270. Again divided with 2, 13 with remainder 1. Again divided with 2, 6, remainder 1. This is 2 3s 6, remainder is 0. Again 2 1s are 2, remainder is 1 until this is 0. Now the remainder is 1. Now should take the values from bottom to top. So these are the binary values for integer part. Okay. So for the integer part, the value is 110110100 point. Next fractional part multiply with 2. That is 0.7 is multiply with 2. This equal to 1.4. The integer part in this product is 1. Now take this fractional part again 0.4 into 2 which is equal to 0.8. This is 0. Next 0.8 into 2 which is equal to 1.6. Again this is 1. Again 0.6 into 2 which gives rise to 1.2. This is 1. Next 0.2 into 2 which is equal to 0.4. This is 0. Similarly 0.4 into 2 which is equal to 0.8. This is 0. Again 0.8 into 2 which is equal to 1.6. This is 1. You can see here it is 0.8. This is also 0.8. The same product is repeated. That's why we should stop the process of multiplication at this place. For fractional part, we should take the binary values from top to bottom. 10110. Okay. This is the required binary number. In the same way, we can do decimal to octal conversion. This is just like decimal to binary conversion. But here, instead of 2, we should use 8 only. That means the integer part should divide with 8 and multiply this fractional part with 8. So now let us do the conversion. This is integer part 436 by 8. 8 5s are 40. 8 4s are 32. The remainder is 4. Now 8 6 are 48. This is 6 remainder. 8 0. The remainder is 6. Okay. Now we should take the values from bottom to top. So the integer values are 664 point. Similarly, for a fractional part, multiply with 8. The fractional part is 0.7, multiply with 8. So this is 5.6. From this, we should take the integer value. This is 5. Now, we should again multiply this fractional part with 8, which is equal to 4.8. Here 4. Again 0.8 into 8, which is equal to 6.46. Next 4 into 8. Which is equal to 3.23. So just 4 to 5 multiplications is sufficient. Now we should take these integer values from top to bottom for fractional part. The values are 5, 4, 6, 3. Okay, this is our octal value for the given decimal number. Next, the third conversion is decimal to hexadecimal conversion. This is also just like the previous conversions. Instead of 2 and 8, we should use 16. So the integer part divided with 16. The fractional part multiply with 16. The hexadecimal digits are 0 to 9, then A to F. Okay, we should remember these are hexadecimal digits. Okay, we should use these digits only during division and multiplication. Okay, now let us take the integer part 436 by 16. 16 2s are 32. Here it is 43 minus 32, which is 11. Okay, 116. 16 7s are 112. Okay, so it is 7. The remainder is 4. Okay, next here it is 16 1s are 16. The remainder is 27 minus 16, which is 1. 11 means its equivalent hexadecimal digit is B. Okay, because A is 10, B is 11, C 12, like this, F is 15. Okay, so this is B. Now again divided with 16, this is 0, its remainder is 1. Now again divided with 16, 0, this is remainder 1. Okay, now we should take the values from bottom to top. Okay, for integer part 1b4 point, for fractional part multiply with 16, 0.7 into 16, which is equal to 11.2. But here we should use 11 means instead of 11 we should replace with the b. Therefore this is a b. Now multiply with the 0.2 into 16, which is equal to 3.2. This is 2. Now multiply with the 2, 16, which is equal to 3.2 repeated. So we can stop the multiplication at this level. Now we should take the values from bottom to top. So these are the values of fractional part B3. Okay, this is our required hexadecimal value for the given decimal number. This is our answer. Okay, I hope you understand this concept. If you like my video, please like, share and subscribe to my channel. Thank you.